Good morning, students. Today I will cover the topic photo detectors. In photo detectors, the basic agenda is related with the basic concept with the photo detector, then practical case study. Then I will explain the characteristics involved or associated with the photo detectors, responsibility of the photo detectors, and how the direct and indirect band gap is related with the photo detectors. And finally, we'll conclude with the system model of the photo detectors. So first, I will start with the basic concept. As you know, the photodetector, also known as photoconductor and photodiodes. As we know, there are three basic building blocks of the any communication system: the transmitter, channel, and receiver. And as you know, the channel is the very important part because that was analyzed with some channel modeling and different mathematical modeling is required because channel is not in your hand, but as far as the transmitter and receivers, you are able to see, you are able to touch. So analysis is a bit easier than the channel. As far as the optical fiber communication concerned, the transmitted part is consists with the led and laser, and you already know uh, when the LED will be applied, when the laser will apply. In the summary, the LED has the wider spectral width, and laser has the lesser spectral width. And since the wider spectral width have very difficult to switching, and lower spectral width can switch more. So the data rate supports in the LED is lower because the spectral width larger. So on off time is larger, and at the same time laser the spectral width is very lower. So the switching speed is easier. And the same I already told many times why for the high speed data rate LEDs will not support because peak overshoot phenomena is appeared due to high switching speed. At the same time, uh, the channel, a lot of the bigger concept is related with this channel because I have already covered the window techniques, absorption, attenuations, banding loss, coupling loss, material loss, waveguide dispersions, material dispersion, resultant dispersion, that is the chromatic dispersions, how the V number is related with the V number, how power in the core and cladding will be distributed. So here uh, I was already uh, covered this LED and lasers. Now here the channel, since I've already also explained why the channel is very important because they will able to transmit lower uh, frequency as well as the higher frequency band. And at the receiver here, the today's agenda is this one detector. So in the optical communication system, uh, when we'll transmit the signal is analog signal, right? So uh, you want to transmit your hello signal to hello to your mom, and if you will tell hello mom, how are you, so the same message should be received by the detector. And uh, and here detector will be directly connected with your mom device, and she also wants the same message, right? uh, so what are the main function associated with the detector is after the detector, the filter is very important because if all the natural signal is a low frequency associated signal, and we also wants to receive the low frequency signal. That's why always the receiver end the low pass filter is there. And as far as the channel, high, we are looking for the high as well as the low both. So band pass filter nature will always incorporate with the channel, right? So today's agenda is only the detector. So see here, here is the electrical signal. Electrical signal is converted into the optical, and optical is again converted into electrical, because those forms you will send the information in the same form you want to receive the signal, right? So electrical, so fine, here is the electrical, so electrical domain, so you also wants to receive the electrical signal here, right? So here electrical to optical, and here optical to electrical. So what is the concept here? Electrical to optical, who will the responsible? LED and laser. And here the optical to electrical, who is responsible? Detector, right? So anyone ask how you can define the photodetector. So one line concept is detector can convert the optical signal into electrical signal, right? So this is the basic concept related with this one. And always remember, at the receiver side, low pass filter is required, because the natural signal is always the low frequency associated signal, right? Now, the basic, the practical case study with the optical communication system. In any time in the real or practical scenario, if you want to judge as an engineer, where is the electrical component is there, where is the optical component is there, so just line coding is there, right? Line representation is in optical communication system. Yeah, input signal is always behaves as the blue color. If you in practically, if anyone told you, please give the idea where is the optical signal, where is the electrical signal, where is the reference signal, so just remember that the electrical signal is always the blue signal, right? And the optical signal is always the green signal, and electrical signal is the blue, optical signal is the green, and reference signal is always be the red signal, right? So this is the basic concept, right? So here you can see input signal is electrical, LED laser converted into optical, and optical is again converted into electrical signal. This is the again blue, so blue will send, blue will receive, and in the entire process in the optical domain. And always remember that reference signal is a measured as the red signal. So I will show uh, one practical case study in later phase with the Opti system tools. And since you know that you people already done and completed some labs in your lab, so and I will also provide some uh, latest lab. First, I will do myself and send the same videos to all of you, right? So I hope till these two slides, what is the conclusion? Uh, you want to send the electrical signal will be converted into optical signal by LED and laser, and at the receiver end, detector will convert again optical signal into electrical signals. And what are the representations? Electrical signal is always as in a blue color, optical signal is the green color, and the reference signal is the red color, right? So now in the later slide, where I will only consider about the pin or Evanche photodiode. So first I will give the basic idea about the photodetectors. Now, so before you analyze the photodetector system model and the real-time analysis, first you should know what are the characteristics involved with the photodetectors. So see, in optical communication system, data can be sent from up to 10,000 kilometers, and data rate up to maybe 160 Gbps, more than 160 Gbps we are looking for. Currently 40 Gbps is already deployed many country. We are also through the NKN we are assessing up to 10 Gbps data, right? So think precisely without see this slide, what are the natures should required for the photodetectors. So anyone can judge, since the data is coming from up to 10,000 kilometers or 500 kilometers or 100 kilometers. Let us you want to send the information from SMBDU to Jammu. Let us assume that 60 kilometers near about the distance, and and someone wants to send the information inside the SMBDU campus. So which type of source do you have required, right? So for the low distance communications, we always prefer the LED because spectral width is larger, switching speed is less. And for the longer distance communication, we always looking for the lasers because the spectral width lower, switching speed is high, on off is very easy. So and coherency and other characteristics will explain later which. But this is the basic concept related with the spectral width, right? So what do you think? The which properties is required for the photodetector? So no doubt for the long range communications. So the response of the photodetector is very high. Just they will observe the signal, they can able to sense and response in what matter, since we know uh, there is some threshold voltage. Let us assume that 5 voltage is the threshold voltage for the output one. If the voltage is 4.999, then again the output is 0. So this type of sensitivity is not uh, uh, fulfill the requirement of the photodetectors. So response as well as the sensitivity is very high is required in the case of photodetector. Just sense, and after your uh, uh, photodetector just sense, but the threshold is very low, so output is, instead of 1, output is 0. So after the photodetector, we will induce regenerator, 3R regenerator in the practical case study. So that signal will regenerate. So after the regenerate, the signal is refresh, and then the output is beyond the threshold voltage, higher the threshold voltage. Then low pass filter is able to cut that that frequency and give the output, right? So the first two cases is very important. Sensitivity is very high, and fast response is necessity for the any photodetectors, either PIN or APD. As far as the wide bandwidth, since the uh, different type of users looking for the different bandwidth, right? And optical fiber, associated with the very large bandwidth. So fin or APD or photodetectors, different type of photodetectors should support the larger bandwidth. Otherwise, every time you can change the, for the lower bandwidth, you can change the different photodetectors, and higher for the different. So not possible, right? So every time you change the detector is not possible. Yes, uh, as far as when we'll explain the pin diode APD, then you can analyze which one is the best one, which one is the ideal conditions. We'll see in the later phase. Uh, at the same time, since uh, a lot of temperature variations maybe appear at the receiver end, right? So if your photodetector should be insensitive uh, uh, with respect to temperature variation, otherwise they will give the unrealistic output, right? uh, because at the time of you have transmitted one, they will give the zero, or zero gives the one, because maybe that due to the temperature variations, your threshold will be shifted from upper or lower, both sides, right? And always remember that uh, uh, output at the receiver end always looking for the threshold value. At the same time, minimum addition of noise. uh, I already told, noise has additive in nature. If uh, one channel give some informations, then other channel at the same time provide some other informations. Let us assume that in your class, I will ask one students for your name, but at the same time other students also reply or response at that the question for that questions for the particular persons that behaves as a noise. Fan in your installed in your classroom, AC installed in your classroom, all will be produce the noise, and all the noise will be edited and provides in a such a manner that your signal to noise ratio is less than one. So, so photo detector is so much uh, smart. They will avoid the noise appear at the photo detectors. And in the photo detector, since the photon is coming from the channels and directly strikes with the very high speed at the junction, so they will also produce the some different type of noise. So yes, uh, photo detector should be able to avoid this type of noise. At the same time, uh, different type of fiber, single mode fiber, multi mode fiber, graded fiber is there. So your photo detectors, yeah, very difficult to for manufacturer company. They will make the photo detector in the different types, right? Different dimensions, right? No. So photo detector should be compatible with the different types of dimensions. At the same time, cost, yes, this is not the conceptual related, but yes, cost should be low. How you can differentiate the cost? If one design engineer design the optical fiber system for the SMDU, and one students design the optical communication system for the SMDU to Jammu. So both will be used. The APD is not suitable, right? For the lower distance communication, always prefer or shorter distance communication. Always prefer the pin diode, and for the longer distance, for the APD. We will explain in later page, right? Yes, long life. Uh, Otherwise, sometimes the unwanted fluctuations or bombardment of the photons, the lifetime of the photodetector may be reduced. So, the cost of pin or a pin is not so much costly, but yes, long life is required. At the same time, uh, distance between transmitter and receiver is also the factor of the pin diode or ABD or photodetector, and the dark current. These 10 characteristics are very important for the any photodetector. Hopefully, you have uh, uh, observed some realistic characteristics, and please don't remember this. Just think which type of characteristics is really required for any photo detectors or for any receivers. Right now, we in these 10 points, one thing is not covered. Your photo detector should be compatible with your receiver for your filter, and always remember that uh, in optical fiber communication we'll always prefer the Basel's filter, right? Basel's low pass filter. And Bessel low pass filter, I think you already know that. Why low pass filter I already explained, because the natural signal always lies on the low frequency, right? So that is compatible with the your photo detector is very important, right? Now after this, uh, I will relate your photo detector with the responsivity, right? Responsivity, this is the graph of responsivity and wavelength. At the x-axis you are able to see this is the wavelength, right? And this is the responsivity. So responsivity of the any photo detector should be high. Why responsibility should be high? I will explain mathematically in the next slide. And responsibility is the ratio of here you can able to see uh, ampere and watt, right? But basically this is ratio of microampere, microwatt, very low value. And this responsibility is higher, is very beneficial for the photo detectors. And this is the wavelength, this is the micrometer 0.7, 0.9, and you if you will convert into nanometer, so this is 750, 950, Oh, I think in the window techniques, you already known these three types of windows: 850 nanometer, 1252, 1350 nanometers, 1552, 1650 nanometers. So here the third window, here is the second window, right? And here is the first window. So see here, here is the silicon, right? Here is the germanium. And if you will go through the any books, all books has explained nicely, but there is some cross graph is there, so some confusion maybe appeared, because when I was read in the first time, then I was also confused. So I have given here very easy way representation of the graph. See, so here, this is the responsitivity. Here is the wavelength, the first window, second window, and third window. And see, silicon is mostly lies in the first window, but responsibility is near about 0.6, that is 60%, right? Here, see, you can see here, Germany. Germany is near about from the first window to second window, right? And when you able to see this indium gallium arsenide, right? So they second window to up to third window, right? And you are already known that which window is better, because third window is better because attenuation is minimum 0.2 dB per kilometer, right? So but see, here the silicon Ly, and here the germanium. So if anyone asks which material is good for the photodetector, so if one is silicon is there, then you can only operate in the first window, right? And if you are looking for the germanium, then second and near about third window. But here the percentage is very lower, 50%. Here, responsibility is 60%. So the first window, no doubt, silicon is good, and second window is the germanium is good one, second or third. But if you are looking for the one materials that is suitable for the all, and efficiency is very high, near about more than 90%, you see, greater than 90%, see. So in that case you are looking for this indium gallium arsenide, that is, this is the Ly, this is the, right, this is the diode band gap materials, right? So there are two types of materials. One is the only the Ly materials, and some other gallium arsenide, indium gallium arsenide phosphide, right? Different type of composition is required. So this type of materials is known as diode band gap. And what is the indirect band gap and diode band gap? I will explain in the next slide. But here you can able to observe responsitivity for the first window is silicon is good one, second to third window, and efficiency, but efficiency is very lower, associated to 50%. And if you are for the best suitable device, we are looking for the always diode band gap energy materials, right? So for the what is the conclusion of this graph? For the photodetectors, you should meet your photodetector should be made with the diode band gap, right? Because they can able to support lower bandwidth or to higher bandwidth, wavelength, that is the first window to up to third window, right? So and in this case responsibility is greater than 90%. This is the fantastic. If the responsibility is greater than 90%, is fantastic, because in every instant you can get the output, right? And BER is lower. So, what are the characteristics you will find after the photo detector is BER and SNR, and you have already uh, incorporated some characteristics with your optic system tools, right? Now, see the diode band gap and indirect band gap concept. Here, the energy here the graph between the energy and the momentum, right? Momentum. This is the valence band. There is the conduction band. Here is the electron. Here is the holes again. The same here. I just left this. This one also. Here is also the holes. Holes. Right. Now see. Here is the electrons. But here the alignment is this valley and this are directly directly aligned. But here, see this crest is and this peak is not aligned. So how they combine? Here's this one crest and this one is that this one can align with the very easily, right? Because in the same momentum, same momentum, right? Same momentum. But here the some momentum is change. Momentum is here, but here conduction momentum is here, right? So though both momentum is not aligned, so both will not combine. And once the electron and holes will combine, then only then release the energy, not photons. And combination of energy is known as packets of energy, and packets of energy make converted as a photon, right? So to release the energy, this electron should release the momentum and reached here so that they can combine with these holes. And only this is the only condition when both are combined and release the energy. Here is Eg, here is the Eg dash. So the first question, just analyze which one is the larger part, Eg dash or Eg, which one is greater. So no doubt here is diode band gap, here diode band gap. So Eg should be higher than this small Eg dash, right? So why? So how you can define the diode band gap in our diode band gap? Here the direct recombination from electron and hole release the energy, and here some first momentum release, then they combine, because here the momentum is aligned with the same, because here the momentum axis is momentum, so both are in the same, so they can combine. But here release the energy then combine. So no doubt Eg is always greater than Eg dash. And if you will difference the EC minus EB, and EC minus EB is greater than h mu, then the photon will generate it, right? So here you can also observe Eg is equal to this one, and h mu is Sc by lambda. And so always remember this, diode band gap energy is always higher than the indirect band gap energy, right? Now if you will have the energy between conduction band and valence band, then some last year in 2019 the gate one question was asked in the gate 2019. Please find the wavelength, and energy was given, and simple, this energy gap is 1.24, and just put the value, right? So you can able to find the wavelength in micrometer, sometimes wavelength in micrometer, sometimes in nanometer you have already remember that, 850 nanometer to 950 nanometer, 1250 nanometer to 13950, and 15950 to 16950. First window, second window, third window. So what is the conclusion of diode band gap? Crest and peak both are aligned with the same momentum, the diode band gap energy, and if the momentum released then combined with the diode band gap energy, and no doubt Eg is always greater than Eg dash. Now I am looking for the system model, right? So photo detector, this is the symbol here, you can see, right? Cathode, anode, pin diode. Inside the pin diode, here the power incident with this device. So let us assume that the characteristics vary from x0 to x. Now if the power is incident P0, so if any solid device, if the power incident, some power incident, so some power should be reflected, right? And let us assume that reflection coefficient is R. So P0 is the incident power, so reflected power should be RP0. R is the reflection coefficient. Now the P0 is here, total P0, RP0 is reflected. So inside, how much power is inside? P0 minus P0 into 1 minus R, right? And this, since this device will be the power will exponentially decay, so that's why the nature is e to power minus alpha x, right? So now in the system model, again I explain, if any solid device, just you take the one chalk and forcefully strikes on the wall of your classroom, then some then after the strikes, they will reflect back, right? And that is the, if let's assume that the reflection coefficient is r, then rp0 is there. So, and the power is, since the absorbed power, right, power inside the material is absorbed, so exponentially decay, the power is decay, and that is the factor of p0 1 minus r. Why p0 minus 1 r? P0 minus rp0. So p0 uh, common, so 1 minus r, and since the exponentially decay, so e to power minus alpha x, right? So I think you are able to calculate this. Now we will calculate the power absorbed optical. So p0 1 minus r, 1 minus e to power minus alpha x. E to power minus alpha x is, so total power is 1, so 1 minus e to power minus alpha x. Now we will calculate the photocurrent. Photocurrent can be calculated by the charge carrier by this value, right, h mu. So you can calculate the photocurrent ip is equal to q by h mu 1 minus r into 1 minus e to power minus alpha x, right? So finally we can calculate the responsivity. Why we calculate the responsivity? Because responsivity directly related with the quantum efficiency, right? And why responsivity? So see here this graph, because the photodetector is directly related with the responsivity, and the ratio is, unit is ampere per watt. So see here, so here we see responsivity is ip by p0. So ip is the photo current, and that is value is microampere by microwatt, a very small value. Responsivity, why responsivity very small? They just the small value just amplify by the amplifier and pass through the regenerator goes to the filter and take the output, right? So responsivity is microampere by microwatt. So that was related with the your figure 1, right? So today's class, I have highlighted what are the characteristics required for the photodetector, how your information from transmitter to receiver will proceed, how you can practically able to judge which portion is electrical signal, which is the optical signal, right? And the main important things, which type of material is always considered in optical photodetector is a band gap, like indium gallium arsenide, because in that case you that type of that type of materials can able to operate in all the windows with a high efficiency, right? And the main factor is responsivity. Responsivity should be high, is the main characteristics of the photodetector, and responsivity is nothing but the ip by p0, and that will be calculated with the microampere microwatt. And if you are able to know that the energy, then you are able to calculate the wavelength. So hopefully, my dear students, you are able to understand what is the nature of the photodetector, how the photodetector is very important for the optical fiber communication system, and share this video to all of you. Kindly let me know if any doubt related with this. From next uh, class, I will explain the first agenda in that lecture is pin diode. A pin diode is very, I'm giving just basic idea. In your the first year, all are knowing the PN diode, right? And how PN diode, I'm giving one task to you, how PN diode will be converted into pin diode. Just think about, it's very easy, and I am just giving some clue. Just yeah, the biasing phenomenon is required for pin to pin, and why pin is required, why not other phenomena is required in photodetector, will explain in the later phase. Hopefully you are able to understood what I have covered in this lecture. All the best, and be stay at your home, and be healthy. All the best. Thank you.